Magnetic compasses have been in existence and used for centuries by the ancients. But despite modern-day technological advancements, this ancient instrument is still carried and used on board modern ships today. And it still remains of significant importance in our journeys across the oceans. Hi, I'm Captain Roy and welcome to my channel where I make videos and answer questions about ships. So if you would like to know more about ships, then stay tuned and come on board with me. Most ships carry on board two types of compasses. A magnetic compass, which is also referred to on board as the standard compass, and it can usually be found mounted on a deck that's above the navigation bridge. And the other type of compass carried on board is the gyro compass. This instrument is usually fitted inside the wheelhouse and is usually coupled together with the steering stand, or on some ships placed inside a dedicated room. Aside from the fact that both these compasses have the same fundamental function, which is to provide direction and a means for the ship to be steered steadily on a particular course, what exactly is the difference between the two? In this video, we will examine both, and let's start first with the magnetic compass. As we all know, the magnetic compass gets its directional property from the Earth's magnetism. As long as the Earth continues to emit this magnetism in the same manner as it does now, then the magnetic compass will continue to be a safe instrument for use in marine navigation. Now let's have a look at what a ship's compass looks like. It is usually covered in waterproof canvas to protect it from the weather and the elements. On the top of the binnacle is where the compass is fitted and supported by gimbals so that it remains horizontal and steady despite the motions of the vessel. On each of its sides are the quadrantal correctors. On the front is where the Flinders bar corrector is. And inside of the binnacle are placed various fore and aft and athwartship corrector magnets. All these correctors are necessary for correcting heeling and deviation errors, which we will come to shortly. From its mounted position above, the compass card is made viewable to the helmsman down below in the wheelhouse by the use of periscopic mirrors fitted inside of the binnacle. In this manner, it can be used as the steering compass as well. When using a magnetic compass for navigation, it must be remembered that it inherently comes with two main errors, which is called variation and deviation. Variation is due to the fact that the magnetic North Pole is not coincident with the Earth's true North Pole. Therefore, depending on the geographic position of the ship, there will exist a certain amount of difference between the true North and magnetic North, and this is called the variation. The value of variation can usually be found indicated on the compass rose of navigation charts for ease of reference of the navigator. As navigation is normally conducted with reference to true north, variation must therefore be applied if using a magnetic compass to navigate. Now let's move on to the next compass error, which is deviation. Whereas variation is due to the Earth's magnetism, deviation is due to the ship's magnetism. An iron ship in the building stage gradually acquires a magnetism of its own as the iron is worked, and this magnetism induces an error on the compass called deviation. The amount of deviation induced will have to be determined, and it's usually done by swinging the ship through each quadrant of the compass and comparing true readings and compass readings. Once the swing is completed and the deviation has been determined, adjustments can then be made to reduce the error using the correctors provided, which we had seen earlier. Finally, a residual deviation curve table can then be drawn up and posted on the bridge for ease of reference. Despite being corrected, deviation will fluctuate depending on the geographic position of the ship and the course that it's on. Henceforth, when the vessel is at sea, daily checks of the compass error must be done by the ship's officers. This can easily be done by comparing the compass bearing against the calculated true bearing of a heavenly body, and the deviation found to be recorded. Apart from variation and deviation errors, instrument defects may exist. For example, bubbles may form inside a wet type compass, and it must be corrected by filling in liquid to clear off the bubbles. Now let's examine what a gyro compass is. As the name implies, the compass uses a gyro to obtain direction. But what exactly is a gyro? A gyro is basically a spinning rotor that, when freely suspended, possesses rigidity in space. That means that the direction that it's pointing to in space will remain constant. For example, if pointed at a particular star, it will remain so, and the gyro will appear to rotate as the Earth rotates. Because the Earth spins on its axis and is freely suspended in space, it is a natural gyro pointing towards a star called Polaris, and this will remain constant despite the Earth's movement around the solar system and the cosmos. Gyro compasses fitted on ships are made to be north-seeking. This makes it convenient as navigation is always conducted with reference to the true north. The compass is usually connected to the manual and autopilot steering systems, ship's radar screen, and electronic chart screens as part of electronic navigation system requirements. While a gyro compass machine can give very accurate and steady direction, daily checks must be made to verify any errors that it might develop. This can be done at sea using the heavenly bodies in the same manner as done for the magnetic compass that we had seen earlier. Besides this, it should be inspected on board regularly for any abnormalities, and the instrument must be serviced regularly by professional technicians. In conclusion, the gyro compass is basically an electrical machine that is made to point to true north, whereas the magnetic compass is a natural compass that points to the magnetic north. Although irrelevant in normal navigation, It should be noted that both the magnetic and the gyro compasses become unusable in the polar areas. In the case of the magnetic compass, it's because the Earth's magnetic lines of force are vertical at the poles. And in the case of the gyro, the north direction becomes vertically upward. Modern navigation is now no longer about general direction, but about precise direction, where often the directional accuracy of within 1 degree is required, such as when transiting rivers, canals, coasting, or when making port calls. For these reasons, the gyro compass usually takes preference over a magnetic compass because of its high accuracy, steadiness, and true north orientation. Hence, beside their minor drawbacks and limitations, both the magnetic and the gyro compasses will continue to remain highly important instruments required on board ships. Well, we've come to the end of the video. Thank you very much for watching, and I do hope to see you on the next video.